Hello, welcome back to trigonometry. I want to talk a little bit about the cofunction identities today. And don't worry if you don't know what that means yet, but you will in a few minutes. But we're going to use a right triangle and what we know about right triangles to develop the cofunction identities. I've already drawn out a right triangle right here. This is indeed a right triangle. This is a right angle right here. Let's say that we have a right triangle with sides of length. Well, first let's label them. This vertex here we'll label A. This vertex here we'll label B. And this one we'll label C. And let's say we have sides of length 77, 36, and 85. And let's go through and identify what all the trig values are, all the sine, the cosine, tangent, etc. Let's identify what those values are for both of the acute angles A and B. Let's go through and do that work. All right, let's start with A. If you want to find the sine of angle A there, recall that the sine is found by taking the opposite side over the hypotenuse. And here, this is just a right triangle. We don't need to worry about like what quadrant it's in right now because they've gone ahead and labeled the side lengths for us, and they're all positive. So we just go and work with what we've got. So sine of A, we look at angle A right here, and we look at opposite sides length over hypotenuse length. So 36 over 85. And then cosine of A we tackle in a similar way. We look at angle A. Remember cosine, you do adjacent over hypotenuse. Cosine means close, adjacent over hypotenuse. So you got 77 over 85 for that. And then tangent of A. Opposite over adjacent, 36 over 77. Then for our reciprocal identities, reciprocal of sine, we got cosecant of A, so 85 over 36. Reciprocal of cosine would be secant of A, so we get 85 over 77. And the reciprocal of tangent, we get cotangent of A, and that would be 77 over 36. Okay, so there's the values for A. Now let's look at B. Let's get the values for B as well. We're going to go to angle B right here, another acute angle, and we're going to look at, I made that mark over there, so I'm erasing that. We're going to look at what the trig ratios are for it as well. So let's look at sine of B. Now we're focusing on angle B, so we look at opposite over hypotenuse for B, so 77 over 85. Cosine of B. Here's B. Adjacent over hypotenuse would be 36 over 85. And tangent of B, opposite over adjacent from B. So opposite would be the 77, adjacent would be the 36. There we go. And then let's do reciprocal identities. Reciprocal of sine is cosecant. So cosecant B takes the 77 over 85 from sine of B and flips it, does reciprocal, 85 over 77. Secant of B, that's the reciprocal of cosine, so we're going to get 85 over 36. And then cotangent of B, that's the reciprocal of tangent, so we're going to get 36 over 77. Okay, so that's all of the trig ratio values for the acute angles of this right triangle. A and B were acute angles. C is a right angle. A and B are acute. They're more than 0, less than 90. And we've gone through and found sine, cosine, tangent, cosecant, secant, cotangent of both. Now I want you to take a second and kind of stare back and forth between the values for A and the values for B. I want to see if you notice anything. Now if you need another minute to stare, to try to notice something, by all means pause right now. But I'm going to go ahead and point out what I'm hoping you're noticing. So if you haven't noticed it yet, pause. If you have, keep listening. But you might notice that the sine of A is the same value as cosine of B. You might notice that the cosine of A is the same value as sine of B. You might notice that the tangent of A is the same value as cotangent of B. You might notice that the cotangent of A is the same value as tangent of B. You might also notice cosecant and secant and cosecant have similarity there. Cosecant of A has the same value as secant of B. And the secant of A has the same value as cosecant of B. Now if you take any right triangle and you find all of your trig ratios for your acute angles on your right triangle, this is going to happen every time. The sine of A is going to equal the cosine of B. Cosine of A is going to equal the sine of B. Tangent of A is going to equal the cotangent of B. Tangent of B is going to equal the cotangent of A. Cosecant of A is going to equal the secant of B. Secant of A is going to equal the cosecant of B. And this gives us something that we call the cofunction identities. If you look closely at this right triangle here, A is an acute angle, C here is a right angle, B is another acute angle. Now all three angles have to add up to 180 degrees. Measure of angle A plus the measure of angle B plus measure of angle C has to equal 180 degrees because it's a triangle on a plane. But we also know that angle C here is 90 degrees because it's the right angle. So that must mean that angle A and angle B add up to 90 together. So you could say that measure of angle A equals 90 minus the measure of angle B. Or you could also say vice versa, measure of angle B equals 90 minus measure of angle A. And we can use that to write up our cofunction identities. We know that sine of A is the same thing as sine of B. And that's going to be true for these right triangles every time. But sine of B can also be written, or it means cosine of B, excuse me. Let me undo that. I was thinking ahead and not thinking well enough. Let's go backwards. Okay, sine of A is the same thing as cosine of B. Right here, sine of A and cosine B, the same value. And B can be written as 90 degrees minus A. So we could say that's the same thing as cosine of 90 degrees minus A. We could go through for each one and do this. We can say, well, we know cosine of A is the same thing as sine of B. So that's going to be the same thing as saying sine of 90 degrees minus A. We know tangent of A is the same thing as cotangent of B. So we can say it's the same thing as cotangent of 90 degrees minus A. We know cosecant of A cosecant of A is the same thing as secant of B. So we could go ahead and write that as secant of 90 degrees minus A. The secant of A had the same value as the cosecant of B. Why do I keep doing that? Sorry. Cosecant. I was like starting to write it, the whole thing out instead of abbreviating it. Cosecant of B, so that's the same thing as cosecant of 90 degrees minus A. And so forth. Let's see, we did tangent of A. Oh, we could also do cotangent of A. We saw that cotangent of A. Same thing as tangent of B. So we could say, well, that's the same thing as tangent of 90 degrees minus A. And if you need to reverse that, if you need to do, if this is sine of B, that equals cosine of A, you could switch it back and forth. But basically what it's saying is that the sine of one angle is equal to the cosine of its complement. Because remember, two angles that add up to 90 degrees are complementary. So the cofunction identities, is basically what we're saying here, is that the sine of one angle equals the cosine of its complement. Cosine of an angle equals the sine of its complement. Tangent of an angle, same as the cotangent of its complement. Cosecant of an angle, same thing as secant of its complement. Secant of an angle, same thing as cosecant of its complement. Cotangent, same thing as tangent of its complement. And these are called cofunction identities. So once you find one value, you can easily find a bunch of other values too, using these. Okay, well that's all I wanted to say for now about cofunction identities. Just to give you a couple little examples of what you might have to do with these. You might be given a problem. It might say, okay, take sine of 9 degrees and write it in terms of its cofunction. Well, if you're going to write in terms of that cofunction, you would say cosine of 81 degrees. If you were to say cotangent of 76 degrees, to start with, the cofunction would be tangent of 14 degrees. If you were to say cosecant of 45 degrees, same thing as secant of 45 degrees. Hey, let's put this in the calculator and prove that this happens. And that's the way, too, you guys get a little demo of putting this into the calculator. Your calculator is probably not going to have cotangent, cosecant, or secant buttons or functions. So you'll probably have to take cotangent and put it in as 1 over tangent of 76 degrees. You'll probably have to take cosecant and put it in as 1 over sine of 45 degrees. And you'll probably have to take secant and put it in as 1 over cosine of 45 degrees. But let's pull up the calculator here. I got mine on the computer here that I can use. Let's first of all check your mode. On your graphing calculator, there's a little mode button right here. Press that, and if you look down, we're dealing with degrees, like sine of 9 degrees. So you want to scroll down and then scroll to the right and hit enter to select the degree mode. Because if you're in radian, you're not going to get the same answer. We haven't talked about radians yet, but radians are something else. You would get an entirely different answer. So you want to make sure if you're dealing with degrees that you're in degree mode. And you check that on a regular basis. I don't know what I just tapped by accident. Go back to mode. Okay, that looks fine. Alright. Okay, so Sine of 9 degrees. What we can do is hit the sine button right here, type 9, parentheses, hit enter, and it gives you the value for sine of 9. But let's also do, sorry about that, this pen is sensitive. Let's also do cosine of 81 degrees. Hit enter, and look, they come out the same. That's what happens with cofunctions. Cotangent of 76 degrees, instead we got to put 1 divided by tangent of 76. Don't use the tan to the negative 1 right here. That is something different. That's an inverse tan. We haven't talked about it yet. We will in the near future. For cosecant, cotangent, and secant, you need to do 1 divided by, say tan, sine, cosine, whatever. Don't use these sine -1, cosine -1, tangent -1 for that, because that's something entirely different. Alright, 1 over tan of 76, we get this. And then if we do tan of 14, we get the same thing. So remember, cotangent of 76 and tan of 14 are cofunctions. They come out with the same value. Cosecant of 45 is 1 divided by sine of 45. We get this. Then secant of 45 is 1 divided by cosine 45. We get this, get the same thing, as expected. So that's what happens with cofunctions. If they're cofunctions, like the sine of 1 is the same as cosine of the complement. Cotangent of 1 is the same as the tangent of the complement. Cosecant of 1 is the same as the secant of the complement. Alright, well that's enough about cofunctions for now. Please tune in again in the next podcast, and we will talk more about some angles, talk about some special angles and so forth. So just stay tuned, come back, and thank you for joining us.